Okay, here we are on the second page of the line dilation lab that we did in the computer lab with Geometer Sketchpad. And as usual, we have to follow the directions step by step. Step 8 here says select tab 2 at the bottom of the page. I'm going to go over to my Geometer Sketchpad file and do that to open the coordinate plane. It also says mark the origin as the center by double clicking on it. Okay, so tab 2 right down here. There's the origin, double click. Okay, and that flash tells me that I have successfully marked it as the center of dilation. Step 2, or the next step, says move points A and B to plot the line y equals x plus 1. That's the first line here. Remember, 2 points define a line. The easiest point to plot is the y-intercept. So that's the first one I'm going to do. And then if this has a slope of 1, that helps me figure out where else to plot a point. So to plot the point y equals x plus 1, I'm going to move one of my points to be the y-intercept of that line, and move the other point such that the line has the correct slope. The line is supposed to have a positive 1 slope because it's y equals 1x plus 1. So I'm going to move the line. I'm going to move point B right there. Then it says dilate the line by clicking on the line and then selecting transform dilate. So let me click on the line. Transform is up at the top. Sorry, you can't see it. Dilate. Record the equation of the new line. Note that dilating any 2 points on the original line results in 2 new points defining the dilated line. Fill in the table. So the first one it told me was to dilate by a scale factor of 3. So that would be 3 over 1. Okay, so here it is. It says, note that dilating any 2 points on the original line results in 2 new points. It actually told me just to click on the line, but I'm going to go back and redo that again with those points also selected. So transform, dilate, dilate. Here are my 2 new points. Okay, so fill in the table. When I dilate by a scale factor of 3, here's my new y-intercept. It's 3, and here is my slope. It's up 1, right 1, up 1 over 1. You could also use slope formula to find it right there. So I'm going to put y equals x plus 3 in this spot right here. Y equals x plus 3. Okay, so this is what I'm doing point for point, or going through this chart one at a time doing this. The next one says dilate by scale factor 1/2. So I'm going to go ahead and get rid of this. I'm going to undo my construct, and I've already marked it as the center, but I just want to make sure I've got it right. Scale factor of 1/2, transform, dilate, change it to 1 over 2, and here you have it. Your new y-intercept is 1/2. The slope, look, it's parallel to the old one, so it's going to have the exact same slope. No matter what I dilate it by, you should notice it's always going to have the same slope, no matter what my scale factor is. This is 5/2. How about 5? Whoops. That's a scale factor of 5. This one I'm dilating the second one. I'm dilating the result. So let me go back to the original. There we go. So no matter how I dilate this, there's a scale factor of 5. Here's a scale factor of 10. You can't see it very well. Here's a scale factor of negative 3.5. That's negative 7 over 2 is negative 3.5. Scale factor of negative 1/2. It's always, no matter what I plug in here, parallel to the original. That's going to be the same always. That's always going to be true. That's basically one of the things you're discovering. So that means on this form right here, all the way across, no matter what I dilate it by, I'm going to have the same slope. So in other words, this has to be y equals 1x plus something. This has to be y equals 1x plus something. Okay, and we've already started to notice that the y-intercept, since the y-intercept is just a point like any other, okay, it's 0, 1 on the original. Whatever I do to it, since I'm using the origin as my center of dilation, Whatever I multiply by, whatever my scale factor is, I'm going to multiply that point by. So if it's 3/2 instead of 0, 1, it's 0, 3/2. So my intercept will be up here at 3/2. If my scale factor is 4, my y-intercept goes from 1 to 4. If my scale factor is -5, my y-intercept goes from 1 to -5. So basically what you're going to see on all of this, and you can check your work as you go across, is that on any line, they're all going to have the same slope, and you will get the y-intercept by multiplying the original y-intercept by each of the scale factors. Okay, looking below there, it says, what is true about the orientation of a line and its image after dilation? You should have said something along the lines of the orientation of the image remains the same as the orientation of the pre-image. It doesn't turn. It's kind of facing the same way. That's basically what orientation means. How's it turned? How does the dilation factor affect the slope of the line? Not at all. The slope of the image is the slope of the pre-image. How does the dilation factor affect the y-intercept? The same way it impacts every other point. The x-coordinate and y-coordinate are both multiplied by the scale factor. Since the x-coordinate is 0, it remains 0, so we're really just having to multiply the y-coordinate by the scale factor. This is assuming that we have our center of dilation at the origin. And that's all there is to it on this second sheet of this work, on this lab, excuse me. Ta-da, fini.